session. Today we host DAGsHub for the second time. I'm very happy that it's starting to be a tradition of hosting DAGsHub at least 2 times a year in our wide data program. So today it's not our usual Tuesday day due to Yom HaZikaron on Tuesday, so we moved this session to Sunday. Hopefully you didn't have to change too much in your plans. This session is recorded as usual. Neil, thanks for taking your time for preparing this session and leading it. The stage is yours.
Thank you very much. So can you hear me, guys? Everyone can hear me?
Yes.
Yeah. Amazing. So
let's switch on cameras for just a few minutes to see each other.
It can be nice. Great. So hello everyone. Good afternoon. It's a pleasure being here today and e-meeting you. Although the circumstances doesn't allow us to meet in person, I assure you that we have multiple events under our belt, and hopefully this event is going to be as good, if not even better, than in real life. So my name is Nir Barazida. I'm a data scientist at DAGsHub, and a bit of background about myself would be, I would say that I'm a bit of a round player with a diverse background. I used to be a public speaker and advocate for a global nonprofit organization, raising $125 million in the past 5 years. I'm a structural designer doing analysis for loads and earthquake with a bachelor from the Ben-Gurion University. I'm a Israeli representative in world marathon competitions. And my biggest passion and why we're all here today is data science. So I started my machine learning path as a machine learning expert for Wolti, which is an Israeli company that improve mortgage rates for its customers. And during my time there, I really liked exploring different fields such as front end, back end, and the thing that brings everything to life, which is DevOps. And when I heard that the data science developer position is opening up in DAGsHub, I thought that this is my dream job and I have to apply. And thank God I got the position, or thank to Dean and Guy that are here with me today. I started working as the data science developer for DAGsHub. And what is DAGsHub exactly? What are we doing? What is this product? Why are we here today? I rest assure you that everything is going to be much more clear later on, and we're going to dive very deep into the details later. I want to start with introducing the team that is here with me. Dean and Guy, would you care to introduce yourself?
So hi, everyone. I hope you remember us from last time, but if not, I'm Dean. I'm one of the founders of DAGsHub. It was a pleasure being here last time, and this time we get to dive into the core of the sort of MLOps and tooling and everything. So it's going to be awesome.
Yep. And hi, I'm Guy. You should remember me as well, I hope. Yeah, have fun. Neil, go for it.
That was a long one, Guy. So let's get this show on the road with sharing screen. So hopefully it won't take 10 minutes. Can you see my screen? Nod if you can. Great, amazing. So today's workshop, when planning this workshop, we thought a lot about what will benefit you the most and prepare you for your future job as data scientist. And we decided to explore a real world problem the data scientists encounter in their daily job. And what is it? The data science teamwork. And what do I mean? Working in a team in a production-oriented environment. This can be a very challenging task, and it will affect our workflow as data scientists and even our productivity. Then we will try to think about the solution and what will be the components of an ideal solution and how we can solve it. And we will choose 2 of the most, I would say, valuable or elements of the solution and explore their what and how. And I mean to how can we version and track our data files and models, and then how can we easily by that manage our experiment and our entire data science project end to end. And lastly, I would say the most valuable or value of this workshop, I would say, will be the hands-on experience that you're gonna get. We're gonna learn about two tools that enable us to version our data, which is DVC, and to track our experiment, which is MLflow. Those are very powerful open source tools that we will learn about them, how to use them, and you're gonna gain hands-on experience using them. So I think I spoke quite a lot so far, and I would like to give the stage to you, or in this case, in the Zoom session, the mic or the chat, and to ask you the following question. What difficulties did you encounter while working on a data science project in a team? Try to think about the previous project that you've done in YData or the current deep learning project that you're doing. What kind of challenges did you encounter while collaborating with other people, maybe trying to manage the data, trying to manage the entire components of the project? Feel free to open your mic, cameras, chat, whatever. I'm here to hear you and think about it together. Now we can also see the chat. So anyone, feel free, think about your deep learning project. How did you manage your data? How did you gain access to the data from for all the team members? How was it for you?
I think data versioning is a very big issue, and tools like DVC really helps with this task.
Did you use DVC?
Yeah, we use DVC in our industry project, and so far it does the job really good of versioning. And
where did you store all of your data?
We store the data in Google Drive that we got some storage from the company. We store all of our models and stuff there. That's our remote.
And your code file was stored on GitHub, I guess, right? Or on the platform that the company uses. So you had two different places to store the components of the project. Am I correct?
Yeah, the code is in GitHub and the data is in Google Drive.
Nice. So you covered two of my main points. And to the third one, how did you manage your experiments trying to explore new hypotheses, new processing system of the data, hyperparameter tuning? Did you keep track of the different experiments, or you just randomly checked it and then try to recover previously experiments, or the experiment who were successful?
The other one.
A bit of an in-deep answer. What do you mean by the other one? Would you care to elaborate?
There wasn't really a process to how we version our data, and I mean that's why one of the reasons why we're here today, to understand how to do it better.
Nice. So you didn't have like a way to log your experiments or your work. Did anyone else have a positive experience doing it? Silence as an answer might be a good answer for this workshop, I would say. So you gave a lot of good answers, and even answers that you didn't answer are good for this workshop. And why is that? Because we're going during this workshop to go in deep to the how to log our experiment and manage our project while working in a team, and need to manage the entire components and gain access to all of the team. And what are the challenges in data science teamwork? So I would start by saying that onboarding is extremely hard. Data science project is composed from various components, code base, data, models, experiments. understand every element separately and then understand the entire pipeline can be a very challenging task. Secondly, synchronizing the project components. Think that one of the team members is working on processing the data, while the other one is working on modeling. The one who is working on modeling needs to know on which version of the data and how it was processed to enable to know which model performed better and why. And because of this, managing the project become more of a task than a working state. And this is very problematic. Another thing is the project history. Data science is a research-driven field. And having the last result of the project or the best result of the project isn't the desired state, because we don't want to repeat searching for the same solution twice. It can be time consuming and we don't want to waste our time. Another thing is debugging. Debugging a production model or working to fix a bug for the production model and finding the root cause can be very challenging. Try to think that you only have a pickle file of the model and you need to understand what data it was trained on, what processing method did you use, which model is it? Would it be, if we're talking about the regular models, the machine learning models such as sklearn or logistic regression, you won't even know which model do you have in hand. And lastly is reviewing. Reviewing other people's work is very challenging because it's very hard to understand what was the process, what was the research that end up to this result. And all of these challenges affects us as data scientists. And first and foremost, it's going to affect you and the future you. And what do I mean by that? Most of the time you will collaborate with the future you, trying to maintain a production model that you deployed, let's say a month ago, 2 months ago, or 6 months ago. And you're going to have to understand what research was done, what did you did there, and think how much time it can take you. Will you miss something because you didn't log it properly? It can be a very challenging task. Another thing is increasing women or manpower on the project. Think that you have a very strict deadline that you need to deploy the model to production in this deadline, and you need the help from your friend. How much time is going to take him to onboard to the project and to increase the productivity? You will probably spend more time debugging and managing the project rather than scaling it. Or as a team lead once told us, I put 200% manpower to get only 120 output. Reviewing work. So think that you want to deploy a model to production, and the reviewing is going to be very long. It's going to take a lot of time. So either deploying it to production is going to take a lot of time, and then you're going to miss your deadlines, or it won't be reviewed very in deep. It's going to be reviewed very superficially. And therefore, the risk for bugs in productions are very high, and you don't want to be in this place. Lastly will be the knowledge management. Think that your colleague left the company and you need to take the project from where he left it. Your boss obviously wants you to deliver it fast and on time. However, you don't really understand what is going on there. So you will be in between the pressure from your boss and moving fast and understand the project history, and therefore logging the project and having the knowledge management of the project is crucial. However, all of this might strike a bit high level or maybe remote to you. And therefore, I would like to share from my experience as a data scientist working in a production-oriented environment. And when I worked as a data scientist, the entire process of logging my work was ad hoc. There wasn't a workflow or a way to log our process properly in my company. And every data scientist logged his work separately. Some really did it in depth and some didn't really log it. They just saved the Jupyter notebook and that's it. And at one point I was asked to improve a model that was in production. And this model was just simply classifying the user based on certain criteria and his behavior on site. all I had was pieces of information. I had the pickle model, a very, I would say, extremely long Jupyter notebook, and some raw data set and the process data. I had more questions than answers. I didn't know what model was the pickle model. I didn't know on which data set it was trained on, what was the raw data set, what was the processing method, what hyperparameter were used. I was really frustrated at this point. So I decided to...
Sorry for that. You said pickle model? Oh.
Yeah, when you deploy a model to production, you usually need to wrap it as a pickle file, and then you can reopen it as a model in the backend.
Okay. Thank you.
So so the model, I didn't have a lot of information, and therefore to try and overcome these challenges, I created some patches that then become the workflow in our company on how to log the experiments and the workflow. And what I decided to do is log my workflow to an Excel sheet or a Google sheet, so everyone would have access to it, and attach it to the project. However, it was still very time consuming. I had to spend a lot of time managing the project rather than research for the problem. Every new hypothesis took a lot of time to explore and compare to the previous results. And when I failed and I reached to a dead end, I had to go back to the previous stage was very hard. What commit was it? What was the model output? What metrics do I needed to recover? It was very hard. And to sum my experience in a sentence, I would say that it was very time consuming to manage the project and logged it on one hand. And the pressure to deliver to production was very big on the other hand. And in between, it was me trying to managing all together. And after understanding the challenges and the problems that we have, I see that we have some chat messages, so I'll try to address them. Thanks, Dean. And if you, by the way, if you have any questions, feel free, as Rinat, I think it was, right, Rinat? Yeah. So as Rinat opened her mic and asked it, feel free to open your mic, ask questions. And if you rather ask them on chat, we have here Dean and Guy that can also answer. So this was a side note and a way for me to drink some water. So. Okay, so after understanding the problem, let's try and think what will be the element of solution that we can build on the product that can help us improve our workflow. So we consider 3 elements for the solution and 3 tools that will create a holistic solution. So the first one, and as you previously mentioned, will be experiment tracking. A way to track our experiment with the ability to compare between them easily. And to do that, we need a way to version and save our experiment history. And as I said, the history of the project sometimes will be even more important and valuable than the end result itself. When we manage to produce very good results or what resulted in dead ends. So to version our experiment to be able to have the history of the project is very important. And thirdly, we need to treat our data as source code. And what do I mean by that? To have the ability to reproduce previous work or experiments, we need to treat our data and models and version them as we version our code files as we use Git to do it. And having all of these 3 elements combining with a place to store our data in large files and gain access to this place to the entire team will enable us to review the work that was done on the project and to understand what process we did to every component of the project and what the new pipeline of the project now look like and how the new model performs and to compare between the output of the model will be very easy. And then deploying to production will be as simply as merging the pull request, or as we like to call it, the data science pull request, which also combines the data, the model, and the result of the experiments, will be as easy as merging to the main branch. And to provide this solution to the data science ecosystem, we founded DAGsHub, and we're working to build and even improve it. And our mission on DAGsHub is to enable data scientists to scale their work while working in a team. And I think the most powerful, or I would say amazing example, will be the Omdena project, where 44 different data scientists from 19 different countries are collaborating together on the same project. And for me, I would say it's pretty much mind-blowing. And this project, they have a team that is responsible for labeling the data, another team for processing the data, the third team is in charge of the model, and the last team is in charge of testing the model before deploying to, let's say, to production. And they're able to manage the process and sync all of the components, I would say, or the different teams very easily, and have a functioning pipeline. And I would say it's pretty amazing result of using this platform. And we believe in DAGsHub we believe that standing on the shoulders of giants. And what do I mean by that? We believe that there are a lot of very powerful open source tools that provides part of the solution. And what we think we should do, we should simply integrate those tools, provide some features such the ability to easily compare the different experiments. And by that, it will create an holistic solution for the data science ecosystem to manage their project, work while working in a team, and to scale their work. And before we're gonna dive to the live demo, I would want to ask if you have any questions so far, any comments, any insights that you wanna share. Great. So this would be a great opportunity to see the DAGsHub platform. So what do we see here? So this project is Dean's project, where he is trying to, using computer vision models to predict the depth dimension of 2D image and turn it to 3D. And as you can see here, this is the main repository of the project. It's very similar to GitHub, but it has some more features that are more data science oriented. So as you can see here, we have the main repository tab. We have the experiment tab that we're going to see in a second. And we have the issue, the pull request, the wiki, the watch, the star, and the fork that are very similar to GitHub. And if you're going to go a bit, we're going to scroll a bit down. We have here the ability to compare between different files, and we're going to see how it's easily used in a second. In here, we can see all of the files that we have on our project, but those files are not only code files, but also files that we store on a remote storage. So I don't remember who talked about using DVC and storing it on Google Drive. So with DAGsHub UI, you will be able to see also the data file that you store on a remote storage. So this is very powerful to have all the project components in one place. If you're going to scroll a bit down, we will be able to see the project pipeline. And what do I mean by the project pipeline? We are able to see where we got the data from, what kind of processing method did it went through, the code file that processed the data. Then we're also able to see what files are being tracked by DVC, what files are being tracked by Git, and what are the metrics in every state of the project. And if you're going to zoom in, we'll be able to see what was the train metrics that the model provided. So we can see the root mean square errors. We can see all the different information that we need about the project and also about the test set. And obviously, as we all need the README file, which a new feature that we just launched will be the ability to create a README file that is made out of Jupyter notebooks. So if you're going to take a Jupyter notebook, name it as README and push it to your main repository, you will be able to see it as a README file. Okay, so let's go.
Sorry,
Yes?
I'm stopping you again.
Feel
I
free.
just, maybe it's very clear to the people that came from computer science background, but for me, I don't really know Git, never worked with it. And so I'm not quite sure I understand how the versions, like for example, you show here the data pipeline and the parameters that are being saved. So where is the versions, the different versions, for example?
So Git is a tool that enables us to track and version our files. It was originally, we're gonna dive into Git and how to version in the second part of the lecture, but on a nutshell, Git was designed for software development to version and track our code files. And it also has additional features such as working separately in an isolated environment and then merge our work to the same, they call it a branch to the same place. And with Git, it will, if you're gonna version, let's say a code file, and then you're gonna change some of the context of the code file, Git will notice it. And then you will be able to save the new version of the file to version it with Git. And it will enable you to go back to the previous changes very easily. I think it's very hard to explain Git on a nutshell, but this will be as much as we can in this short time. If you have any further question about Git, I will be happy to answer during the break.
Okay, thank you.
Okay, so let's dive right into I would say, another powerful tool that we have here. So the comparison. We know at DAGsHub that one of the tools that we're using in 80% of the time as data scientists will be using notebooks to explore our data, try to create the initial pipeline. So DAGsHub enables us to easily compare the different changes that were made to our notebooks. So if I'm gonna go and use our compare tool, I will choose a different branch or tag. DAGsHub will show me with the yellow background that this notebook was modified. And if I'm gonna click on the notebook, I will be able to see what kind of changes were done to the notebook, what cell were added, what cell were deleted, and what cell were modified. And this is a very powerful tool that nowadays is lacking in other platforms that for managing projects. And I think for me, it was, as a data scientist, it was pretty much life-changing while working in a team and with other data scientists. And another powerful tool here will be the ability to see the data under one in the same place. So if I'm going to go to the source code where Dean is hosting his data, and I go to the data to the process data and choose the train. I'm in my bedroom, so I'm going to choose bedroom. DAGsHub enables us to see all of the data files that are stored on a remote storage and easily parse them and see what kind of changes were done. And if there were changes between the different data file, it will also enable us to compare them and see them side by side. So we'll see one image next to the other. And this is a very powerful tool because, for example, for Dean, from Dean's project, he chose a normalization process that didn't provide very good result while processing his pixels. He didn't normalize his pixels in the image very well. And he saw it in a UI that the image was completely black. And then while choosing a different normalization method, he was able to compare the two methods and see that in the new one, the normalization provided very good results, which eventually provided this depth image. So I think we pretty much covered the computer vision part, and I would want to go to a tabular data project, where in this project, Guy is trying to predict if posts from Stack Overflow are machine learning oriented or not. So this is more of a sentiment analysis, more of an NLP project, but the data here, it's tabular data. And if I'm going to see the data here, so I'm going to go to the raw data and see the CSV file. DAGsHub will, on DAGsHub, you will be able to see the CSV file in a table and easily parse the table and see how the data looks like, and see and even see what changes were made to the data and compare between different commits. And this, I think, it's another powerful tool that enables us to see our data very easily, especially when talking about CSV files, that seeing them, the raw version of them doesn't provide a lot of information. And now if I'm going to go to the experiment tab, which it's a core feature here, under the experiment tab, we are able to see the different experiments with the parameters of every experiment and the metrics that the model with these parameters and this processing method provided. So in here, we can see for the first model what was the TF-IDF norm, and eventually what was the test set accuracy. And the additional feature here is that it enables us to compare easily different experiments. So if I'm going to choose to experiment and click on the compare, we will be able to see those two experiments side by side with the metadata about the experiment, when it was done, and who made it, what commit was it apart from. We can see the different parameters. We can use a coordinate plot to compare different parameters and metrics. So I can choose more parameters in this case, or more metrics, and easily compare between the two experiments and compare apples to apples, compare the same metrics one to the other. And another thing is we can use chart plots to compare the different experiments and output. So basically, this tool provides us an easy way to compare between the different experiments, but also have the history of the project and all of the process that was done to achieve those outcomes of the model. And lastly, we can see here the data science pull request that I told you a few minutes ago. And in this pull request, we can try and merge not only code files, but also experiment, data, and models. And in this way, the person who is reviewing our work will have the full image of the project and all of the different components, and what was eventually the outcome of this new experiments or new hypothesis. And it can compare this new model and its result to the current model and what we have on our main branch. And if the results are better, all he needs to do is simply go to and click on the merge button. And as you can see here, it's going to merge 170 megabytes of files. So he's going to merge the entire project in one click. And using CI/CD tools, it will enable us to deploy the new project or the new hypothesis or the new model to production very easily. And I would say that this is pretty much will cover the platform and the core feature of it. I would say if anyone has any question about the platform and how we deal with things, if something is not clear to you, or how we address things.
I have a small question. Can you hear me?
Yes.
So I understand what is data and what is code, but what is experiment basically? Like, yeah, when you say that when you merge it, then you save also the experiments.
Okay, so this is a great question that we're gonna dive in deep to it in the second part of the lecture. We're gonna explore in the third part of the lecture, sorry, about the experiment tracking. But when I refer to experiment, I refer to any new hypothesis that we might have about the way that we need to maybe process our data, or maybe add a new, let's say a new feature, so feature engineering, or processing in a different way. So this will be a new experiment because we're trying to explore a new path for the solution and see how the model performs and if we can improve our results. And you can, I think there is a different levels of experiment because you can treat every new change in your parameters as a new experiment, or you can treat more larger changes to your code or to your data or to your models as an experiment. This is more up to the data scientist to decide. And there are two main ways that we will treat on how to create an experiment, which we are going to explore in about an hour for now, in the third part of the lecture. But thank you. Did it answer your question?
Yes, if you're going to elaborate on it, then yes. Thanks.
Any other questions? Something that you want to maybe was an insight that you want to share with us? Really feel free. It's more of I would like it to be more of a conversation than one speaker. It will be great. So feel free to jump in.
Something else maybe, making diff of notebooks is indeed important, but maybe it's even harder to do to handle merge conflicts. So for example, when we work now with my partners, we usually use Git, but we use it very partially. We use it to track the differences, but when we start to diverge to branches, then it's very challenging to merge. So any suggestions here? How to deal with actually merging code, not just.
So first of all, not stepping on each other's toes, so not editing the same cell. I would say this will be the first suggestion. But I would treat working in a team on a data science project, trying to divide the project to the different components. So let's say one is working on exploring the data and processing it, and the other one is working on the model. And if we're talking about deep learning, so model architecture can be a very heavy task, or trying to explore different models. And in this way, it will ensure that you won't step on each other's toes. So because everyone is working on a different components. But if you're working on the same components, yes, it's you're gonna have to have more. You're gonna have to have more conversation and talk with each other and synchronize better between you two.
Okay, thanks.
To maybe add to what Nir was saying, concretely, there's a project that I think NBDime uses as well, which is called NBmerge, which you can use to merge notebooks. I'm not really sure how well it works, but I think the rule of thumb should be usually when you're dealing with merge conflicts, you're probably at the point where you should be working with modules and not notebooks. So it's more relevant if you're doing an end-to-end notebook workflow, but we don't recommend it unless you, for some reason, don't have any other option.
Dean, would you care to add anything else that you want about what we talked about, the challenges, the elements of solution, DAGsHub?
No, I think you covered it well.
Great. Okay, so I think at this point, we're gonna take a 10 minutes break, and we're gonna gather here back, let's say 5:55. So it will be 5:55. Will be much easier to remember. Kostya, any other notes?
No, let's have a break. The second break will be around 7, something like that.
Yeah, so we're gonna have two other sections to this workshop. The first one is gonna be data versioning, and then we're gonna explore experiment tracking. So it depends on the questions and how fast we're gonna cover it. So either we're gonna have one break or two.
Okay, let's have a cup of tea or coffee meanwhile. Thank you.
Amazing. So let's just make sure that everyone came back from the regrouping time. So if you can share a message on the chat, so we'll know that everyone returned. We can continue. So just write something in the chat. If you're here, please write something in the chat so we'll know that you're here. Thank you. Before we're gonna start, so we won't miss anyone. Okay. I think we're free to start. Great. So in the previous part of the lecture, we discussed about what are the challenges while working in a team on a data science project. How did this affect us as data scientists? And what will be the element of solution to overcome those challenges? And in this part of the lecture, I would want to focus on the version control and how we can version our data and models better. So you're probably asking yourself, okay, why not simply use Git? So as I previously said, Git wasn't designed for Git was originally designed for managing software development projects and simply versioning text or code files. Therefore, it doesn't really handle large files very well. And then you're probably going to ask yourself, okay, so why not simply use Git large file system? So Git large file system is better at handling larger files, but still it's not good in handling extremely large files, such as computer vision, let's say images or videos, or even very large models. So it's not really optimized for working for data science project. And therefore, a lot of new tools and very powerful tools emerged to overcome this challenge, like MLflow, Pachyderm, and many, many more. However, the most commonly adopted tool nowadays in the data science ecosystem is DVC. DVC stands for Data Version Control, and it's a simple CLI tool for data scientists to manage their project, version their work, and reproduce it. So how does it really helps us as data scientists? First of all, DVC is built as an extension to Git, and it works seamlessly with it. So it enables us to keep working with our most valuable tool, I would say, that is commonly used for software development, data science, or the entire tech ecosystem. Another thing that it enables us to track and version our project components, saving them as locally or on a cloud storage very easily. It also provides us the ability, because of the versioning abilities, it will also provide us easy reproducibility to reproduce our prior work very easily without much of a hassle. It works with any remote storage, so it works with all of the cloud providers such as AWS, Google, Azure, Linode, which is very important. And it works very well with very large files. So according to people who are working with DVC and Git large file system, they really prefer working with DVC because of the way it manages the versioning behind the scenes. And lastly, it's open source. And I must say that I'm an advocate for also for open source tools. and I think they are great, and it supports all of the platforms such as Mac, Windows, Linux, etc. And before we're gonna dive into DVC usage, I would want to first explore the workflow of how to use Git with DVC in a high-level way. And I think by understanding these two next slides, it will be intuitive for you to use DVC if you're already familiar with how to use Git. So in this example, we're gonna have our local directory. We're gonna have our Git tracked files and the DVC tracked files. And what we're going to do, we're going to add a very large file to our project, which is the universe.txt, and it contains all of the information about the universe. What is life? Why do we exist here? Any question and answer that you can think of, it's in this file. And because of its size, we're going to use DVC to track it. And once you're going to add it to DVC tracking, DVC is going to perform two actions. First of all, it's going to tell Git to stop tracking it. And how he's going to do it? He's going to simply add the name of the file to the git ignore file. So if git ignore file is not in your directory, he's going to simply create one. But if it does exist, you will simply add it at the bottom of the file. Secondly, and this is very important, so please pay attention, DVC will generate a new file, a pointer file, that is going to name it universe.txt.dvc. And what this file is going to contain is going to contain metadata about the version of the original file, of version A. So this file is a pointer file to the original, to the version of the original file. And we're going to later on see what it really stores inside. So this is a very important part. The pointer file stores metadata about the version of the original file. And we're gonna use Git to track both of those files. And a rule of thumb here will be that every file that ends with .dvc is gonna be tracked by Git. And we're gonna add it to Git tracking. And as we can see, the current status of our project is that we have version A of the large file that is tracked by DVC, and the pointer file that point to version A that are tracked with Git, by Git. And now let's say that we wanted to maybe process our data differently or create a new feature, and we modified the data file. So now we have version B of the data file. We want to keep it, we want to version it. How are we gonna do it? We're gonna use DVC to version the new version of the data. So we're gonna add it to DVC tracking. And what happened? DVC updated the pointer file to store metadata about the version B of the original file. And behind the scene, it created a copy of the new version of version B. And now what we're gonna do, we're gonna version the pointer file with Git. So we're gonna add it to Git tracking. And let's repeat this process again, just to make sure that we understand it. So we're gonna version it again. We're gonna create a new version of our data. Let's call it version C. And we're gonna add version C to, correct, DVC tracking. And DVC is gonna update the pointer file. And we're gonna use Git to track the pointer file, the new version of the pointer file. And let's say that after using all of the version of the data, we understand that version A is the best processing method of the data, and we want to use version A. How can we retrieve it back? We're gonna start by using Git. So we're gonna choose the pointer file that stores metadata about version A with Git. And we're either gonna check out to the commit that stores it, or to the branch, or reset to the commit. And we can either take all of our project back to this commit, or simply check out to the commit with saying the specific name of the file And this will be the only file that is going to change in our project. So this is a bit of a more advanced process in Git, Git cherry picking, I would call it. And now we're going to simply git checkout and retrieve the previous version of the pointer file. And as we can see now in our local directory, we have pointer file that stores metadata about version A, but the data is version C. And now what we're going to do, we're going to use DVC to retrieve the original file, the original data file. And now we can do it. If it was done locally, meaning you version your data file locally, you will be able to use the checkout command. But if all of these versions are stored on a remote storage, so let's say someone else from your team did all of the versioning and then he pushed it to the remote storage, you will have to use the pull command, the DVC pull command. And what DVC is going to do after running those commands is going to use the pointer file, is going to parse all of the file that he has in his tracking and see which original file matches to the pointer file. And then he will simply replace the file that we have in our local directory to version A. As simple as that. And I would want to stop at this point and ask if anyone has any questions about the very high level process that we just covered, because I think it's going to be very important to the usage of DVC. So if you have any question, feel free to ask.
The metadata file gets rewritten automatically once the data is changed?
Okay, this is a great question. So no, it doesn't change every time the data is changed. It will change every time that you're going to create a copy of your data. So every time you're going to version your data file, DVC is going to create the copy and update the pointer file. So let's say that you now process your data differently and you modify the data file. The data file will have different info. The pointer file is going to store different hash from the data file. And therefore, DVC is going to tell you something was modified. There are changes in your data file that are not tracked. The same as using Git. So let's say if I'm tracking a code file and I'm versioning it, so I would use git add to the code file. And then I'm going to change some lines in the code file. And if I'm going to do, I'm going to run git status, what will git tell me? The code file was modified. There were changes to the code file. So the same with DVC. If you will see that the pointer file stores different hash from what the original data file stores, it will tell you that the original file was modified. There are untracked changes in your data files.
Okay, cool. So basically you're doing two pipelines of like add, commit, push each time. You're doing one on DVC and one on Git.
I wouldn't call it pipeline, but yes, you're using two tools that work simultaneously and they work together to version and track your entire project. So you're using Git to track your small files, let's say your code files, and I don't know, Excel sheets and whatever. And you're going to use DVC to track your large files, such as data and models. But to use DVC, you must also use Git, because you will need to track the different pointer files.
Great, thanks, Neil.
Any other questions? Really feel free. There is no, I would say there is no dumb questions. I would want everyone to ask whatever that is not clear for them, because it's very important to understand this process.
I have a question.
Mm-hmm.
You showed us a nice web interface, and then now we're talking about commands. It's all like integrated. We do the commands on a local terminal, and then we view the results and experiments on the site, or you provide some of that functionality from the site? How
So-
does this two integrate?
To answer both of the questions, so we're gonna see in a second how to use and integrate DVC with the GitHub, with the DAGsHub very easily. And later on, we're gonna also see how to create experiments on DAGsHub also very easily, I would say. So yes, we're gonna cover all the usage of those tools with DAGsHub.
Thank you.
Any other questions? Really feel free. Okay, so I'm gonna carry on. Although DVC is a very powerful and useful tool, it also has its dark side, I would say. DVC assumes that you have some sort of a remote storage configured with your local computer, and if you're using DAGsHub, so you're also with the DAGsHub or with GitHub or whatever. And to do so, you will need to have some sort of DevOps knowledge. If I would take AWS as an example, you will have to know how to create an S3 bucket with permissions, then to define a user with roles that matches to the permissions of the bucket, and then connect everything together to your local computer. And even if you're familiar with the process, it can be a hassle to do it. So this is where DAGsHub comes to the rescue. I would imagine an icon with DAGsHub is Superman, but this is what we have. So basically, what we did, we configured a DVC remote storage automatically with your remote repository, and you have the 10 gigabyte of free storage. And all you need to do is copy and paste 4 lines of commands that we already generated once you create your remote repository on DAGsHub, copy them to your terminal, and it will configure everything together. And all you need to do then is DVC add, DVC push, and you will be able to see them in DAGsHub UI. And how we can do it, and for that, we're gonna cover the DVC 101. So I would say that at this point, we are ready to understand or to learn the usage of DVC and the various commands. And we're gonna go over the very basic of DVC, learn its command that will enable you to track and version your large files and push them to the remote storage, and also configure DAGsHub with your local computer. So we're gonna go over how to set DVC and connect it to the remote, version files using DVC, push file to the remotes, update the version of the files, and lastly, I would say it's more of an advanced use case that is more open source data science project oriented, which is import files from different projects. So let's say you saw a very valuable project with a very good data set, and you want to import those files to your project. How can you use DVC to do exactly that? So I think this is a very important part of our workshop. So if you have any question, once again, feel free to open your mic, ask it. And if you want, you can also use the chat and post the question on the chat. And we have Dean and Guy here that can answer you during the presentation. Okay, so let's dive right into it. So we'll start by installing DVC. So DVC, it's a simple, it acts like a Python package, I would say. And you will use pip to install it. So pip install DVC. I would highly recommend installing it on a virtual environment, on a clean environment that is oriented to this specific project. And then we will need to initialize DVC. So a note here, you will have to be inside a Git directory to be able to initialize DVC. So if you're going to try to initialize DVC in a random directory, it will simply state an error and won't let you do so. So we'll use the DVC init command. And now let's see what new file were generated. So if I'm going to use git status, I will see that two main or two new main files were created. First of all, the DVC ignore file. And the use case of using this file will be when using DVC to track an entire directory, because DVC, as a side note, enables us to track directories or single files. So let's say you have a directory with a lot of images inside, and you want DVC to ignore, I don't know, you have an Excel sheet with all the different names of the images, and you don't want it to be tracked by DVC. So you will simply add the name of this file to DVC ignore. And secondly, as you can see, DVC generated a directory, the DVC directory, that stores all of DVC configuration files. And now what we want to do, we want to configure DVC with DAGsHub remote storage. And now we're going to do it. We're going to go to our DAGsHub directory after we're going to create it. We're going to go to DAGsHub directory. We're going to click on the remote button and then on the question mark next to the DVC remote. And then we're going to copy those 4 command lines. We're going to paste them in our terminal. And let's explore what those commands really do. So the first command is to define a new remote storage with DVC. So it will be DVC remote add. And then we're going to state the name of the remote origin, the remote. So in this case, we're going to name it origin. And the use case here and the powerful feature that DVC stores here, that it enables you to work with different storages in the same project. So let's say you want to store your data in one place and your model in a different storage. You can configure it different remote with DVC and then state where you want to push them while using the DVC push command. So in this case, we're gonna name our remote storage as origin. And then we're gonna add the URL of the storage, which in this case is our DAGsHub repository with the .dvc ending. And as you can see, we are adding the local flag here that state to save those configuration only locally and not push them to our remote repository. And this is very important while working in a team. So you don't want to configure it and track those the DVC configuration and then push them to the remote repository, because it can create conflicts and overwrite your teammates' local configuration while pulling the files. And then we're gonna define the authentication, the username, and every time you want to push file, DVC is gonna ask for your password. You can change this command to add your password or to also add a token that you can generate with DAGsHub, but this is a bit of more advanced use case. So for now, we're gonna simply copy and paste those commands and run them in our terminal. And let's see what changes were made. So as we can see in our local configuration file, we defined a new remote and we called it origin. This is the URL of the remote. This is the username to access this remote, and the other authentication and asking for password every time that we want to push files. And we're simply gonna track those changes with Git and commit them. Any question about how to add a remote and configure it?
Yeah, I have a question.
Mm-hmm.
So the remote, so the data is gonna be stored inside the DAGsHub storage, basically?
Yes.
Can I work with another storage and also use DAGsHub features? Like
yes, so
wire it?
Yes, so we currently support AWS and Google storage, and you will need to define DAGsHub repository and provide it roles. We have everything documented in our doc section on how to do it. But definitely, yes, you can use different storages provider and still see all of the stored data files and models in DAGsHub UI.
Okay, thanks.
I have a small question. In the previous slide, you showed like in green the new files, and there were some plots. Is it like maybe
This?
one before, even before this?
Mm-hmm.
So it detected automatically that there are big JSON files, and they automatically added them, or is it just a random example of like an existing project?
So no, once you initialize DVC, DVC is going to create a DVC ignore file and this .dvc directory that stores the DVC configuration. So those files were created or generated once you ran the DVC command.
So those are not related to your files. Like DVC has files called confusion and plots.
Exactly.
Okay.
And it will cover advanced features that DVC stores, such as creating the pipeline or tracking the metrics and many more.
Yeah, just to add, so this relates, the plots folder relates to a feature that DVC has, which is called DVC plots, which lets you generate plots for your metrics within the CLI and preview it. It might be useful for your case, it might not be, it really depends. DVC saves the formats for the types of plots that you can show in this folder, which means that you can theoretically customize it if you know how to work with Vega plots. But that's why you have this folder, basically. So it's not related to the project content, but you can edit it if you need.
Any other questions? Okay. So to this point, a quick recap. We initialized DVC and configured DVC, our local directory, with DAGsHub remote. And now by pushing files, we will store them in DAGsHub remote storage, and we will be able to see them in DAGsHub UI. And now we would like to add a new data file to our project and track it using DVC. So in this case, I'm going to stick with the universe.txt file. And as you can see, I'm echoing the universe into universe.txt file. And if I'm going to see what my directory stores, it stores only the universe.txt. And now what I want to do, let's assume that this is a very, very large file once again, and we're going to use DVC to track it. And I'm going to use the DVC add command to add it to DVC tracking. So if you're familiar with Git, this command is gonna look very familiar to you. And it's basically 90% of DVC commands are the same command as Git's. So this is very helpful to whomever uses Git. So as you can see here, I added the universe to DVC tracking by using the DVC add command. And what DVC did now, he printed gracefully to me what file were modified, and I need to use Git to track them. So the universe.txt.dvc was created. And I remind you that this is a pointer file to the original file, to the version of the original file. And DVC updated the git ignore. So let's use Git to see that this really happened. And as you can see, if I'm going to run DVC status, I'm going to see that the git ignore file was modified and a universe.txt.dvc was created. And now let's see what those files stores. And if I'm going to print the last 5 rows in my git ignore file, I'm going to see that indeed the universe.txt file was added. And let's see what the pointer file is stores. So as you can see, it stores, first of all, an MD5 hash. And this hash, on a nutshell, version a specific file based on the connection of its bytes. And every time you modify even one byte in the file, it will see that something was changed, something in the hash was broken, and therefore it doesn't match to this specific hash. Okay, so this is a very short explanation about MD5 encoding. And we're going to also see in this pointer file the size of the version of the file that we're pointing at. So in this case, it's only 13 bytes and the path to the file. And now what we're going to do, we're going to use the advice of DVC, and we're going to track those two files with Git. So I'm going to git add the universe.txt.dvc and git ignore to Git and commit it. And now what I want to do, I want to take the data file and push it to my remote storage. And how I'm going to do it, I'm going to use the dvc push command, and I'm going to state the origin that I want to push it to. So in this case, we defined only one origin or one remote storage. Sorry for the phrasing. So we defined only one remote storage and we named it origin. So we're going to state it with the R flag, and the DVC is going to push the file there. Next, DVC is going to ask us to enter our password for our host. So if we're using, in this case, DAGsHub, we're going to need to enter our DAGsHub password. And then it's going to push our files to DAGsHub storage. Next, what we want to do, we want to push with Git our pointer files to DAGsHub remote storage. And why is that? To be able to see the status of our remote storage of our data in DAGsHub UI, we also need to update the pointer files. So in this case, if you won't have a pointer file, DAGsHub won't parse the remote storage and won't show the data files in our UI. So to see the version and our data file in DAGsHub UI, you will also need to update the pointer files in a remote repository. So this is a very important point here. And now let's go to our DAGsHub repository. And as we can,
I'm sorry, I have a question.
Yes.
When you did git push, you assumed that the Git is already configured to DAGsHub remote repository? Because I didn't see a command that does that.
Okay.
We only configure the DVC.
Mm-hmm. So in this case, what I did, maybe off screen, and it's a good point, I simply cloned the DAGsHub repository. So if you
on Git.
Yeah, I git cloned it to my local computer. So just to perfect it, if you're gonna go under the remote button, you're gonna have the git remote repository that you can simply copy and use the git clone to clone it to a local directory, to your local computer.
Got it, thanks.
Any other question?
Yes, but maybe you cover it later. But like in case, for example, we have many files, like a lot of images. Is it common to create DVC file for each, or to zip it and then have one DVC file?
I would say neither. What DVC enables you to track the entire directory, and behind the scene it's gonna run in loop and track every single file there. And if you're gonna modify only one file, if you're gonna add the modification to DVC tracking, you will know that only one image was changed, and it won't encapsulate the entire directory. Okay, so it will only modify the specific image.
Great.
So, you can use DVC to add the entire directory, and behind the scene it will track every image separately. But a note here that if you're going to track the entire directory, you will still have only one pointer file. Okay?
Yeah. Great.
Any other question? Okay. So once pushing the data file with DVC and our Git tracked file, which are the pointer files, to our DAGsHub repository and remote storage, we'll be able to see them in our UI. So as you can see here, we have here the universe.txt file, and you can see the bluish background that I didn't mention earlier that state that this is a file that is stored not on your Git repository, but in your DVC storage. So this is an important information to whomever managing the project. Secondly, we'll be able to see our pointer files that are being tracked by Git, and we'll be able to click on them and see what metadata they are stored inside. So let's go to the advanced use case of manipulating our file, our data file. And in this case, we would want to add Bitcoin to our universe. We will assume that Bitcoin is wonderful. It's a great way to trade and use, and we would want to add it. So if I'm going to add it to my universe.txt file, we will see that it was modified. And this is maybe a bit of an advanced question that don't want me to ask, but I will ask it anyway. So what do you think if I'm going to do a Git status now? What would be modified? What would be changed? Anything is going to be changed? What files are going to be changed?
The .dvc file is gonna change.
You say that it's going to be modified?
Yeah, if you do git status, it will show it has been modified.
Okay. Any other ideas, or maybe a further explanation on why the pointer file was modified? So think about it. What we did now, we simply we modified a data file. So who is tracking the data file? DVC is tracking it. So the pointer file wasn't modified because we didn't use DVC to track the new version of it. So as we're gonna see, if you're gonna use Git status, Git will say that nothing was modified because we didn't add the new version to DVC tracking. And this is also an important point here to notice that only when versioning our data file with DVC, the pointer file is going to be modified. So let's see if I'm going to use a DVC status, what will happen. So as you can see, and this is another command that we're learning along the way here. So DVC has DVC status. And as you can see, DVC is going to tell us that the universe.txt file was indeed modified. So what we're going to do next, we're going to use DVC to track the new version of our file. So once again, we're going to use DVC add universe.txt. And what it will tell me is that we need to use Git to add the modified pointer file. And as you can see also here, it doesn't tell me about the git ignore file because DVC already knows that the git ignore file contains the universe.txt. And let's see what my new pointer file is containing, what it contains. So trust me that the hash was changed. I know it's hard to track it, but it indeed was changed. And also we can see that the size of the file was modified from 13 bytes to 21 bytes. So this was the modification of our pointer file once we use DVC to track the new version. And what we want to do next is simply use Git to track the new version of the pointer file and commit it. So Git add, Git commit. Any questions? Because I'm hearing that someone opened his mic.
I have a question.
Mm-hmm.
Shouldn't we do DVC commit? Like, isn't it considered best practice instead of also do DVC add?
So you can either use DVC commit or DVC add. once you're using, it's more relevant once you're using pipelines and having the entire pipeline tracked. So let's say, okay, so this is a side note because this is a bit of a more advanced question. But to answer your question, to use, if you have a pipeline and you don't want to reproduce the entire pipeline, but you still want to modify and version your data, then you can use DVC commit. Because if you're going to use DVC add in this use case, DVC is going to tell you that this file is already being tracked by DVC, and you don't, and it's part of a pipeline, so you can't use DVC add command. But and therefore you need to use git DVC commit. But other than that, you can use either DVC add or DVC commit.
Okay, thanks.
Any other questions? Great. So at this point, our current status of the project that we added a new, we modified our data file, we use DVC to version it, and we track the new pointer file with Git. But however, at this point, we decided that Bitcoin is very bad to the universe. It's destroying the universe, and we want to drop any remembrance of any memory of Bitcoin in our universe. And luckily, DVC provides us the solution to do it easily. And how can we do it? As we saw previously on the DVC workflow, we're going to use Git to track the pointer file that points to the previous status of our data. So we're going to use DVC log and see which commit is relevant to the previous version of the file. And as we can see, this is the commit, and it only stores the initial universe.txt file. And now what we want to do, we want to check out to this previous state. And in this case, I chose to cherry pick with Git and only version and go back to the previous version of the pointer file, and not go back in and not take back the entire project to this state. So I'm going to use Git checkout. I'm going to state the commit, which is the first 7 figures of the commit, as you can see here. And then I'm going to state the name of the file that I want to retrieve. So it's going to be the pointer file, and in this case, it's the universe.txt.dvc. And as we can see here, one file was updated based on the previous commit. And now what this pointer file stores? This pointer file stores metadata about the previous version of the original file. So as we can see here, it's going to be hard to remember the hash, but we remember that the original file was 13 bytes of size. The size of it was 13 bytes. And now let's see what our current data file stores. So as we can see, it still stores the Bitcoin statement. So the pointer file is pointing to version A, let's say, but the current version that we have locally is version B of the data file. And now what we want to do, we want to use DVC to retrieve the previous version, the version that the pointer is pointing to of the original data file. And we'll simply DVC pull, and we're going to state where we want to pull it from. Another side note here, that in this case, we could also use the DVC checkout command, because we've done the whole process locally, and we have behind the scenes all of the version of our data stored. And as we can see, one file was modified, which is the universe.txt. And what it stores, it simply stores the universe without Bitcoin. So this is the workflow of how to retrieve previous files using a different version of our data files or models or whatever we track with DVC. Any questions about the workflow, something that was not clear that you want me to repeat? Okay, I will take the silence as a yes.
Neil, is this the yellow M? Is it the name of the hash?
So no, it stated that this file was modified. So you're asking about this slide, this M?
Yeah.
So no, it stated that this file was modified. It's M for modified.
Okay, so you just pulled what is now in the origin. But if you want a different version, not the one that's in your local and not the one that's now updated in the origin, maybe a more previous one.
So you need to have the pointer file that points to the version that you want to retrieve. So basically it doesn't matter where you want to retrieve it from. You simply need to have the pointer file to point to the specific version that you want to retrieve. And then if it's stored locally, you're going to use DVC checkout. And if it's on a remote storage, you will use DVC pull. But if you don't have the pointer file, it will be, you won't be able to use DVC to retrieve this version.
But there is a different pointer file for each DVC commit or no?
Yeah, so for every version that you're going to create with DVC, DVC is going to generate a new pointer file. And then it's on your responsibility to track this pointer file with Git. Because if you're going to overwrite the pointer file, you won't have the ability to retrieve the version of the original data file.
Okay, so you are accumulating these pointer files as you proceed with the project. You have more and more in some folder.
No, you use Git to track them. So you will only have one pointer file, but every time you're going to version it with Git, and Git is going to store the copy of it behind the scene. So it's going to make a copy.
Okay, so you go back a commit in Git like to a previous version of the pointer file, then you can use that pointer file to go back in the data. Okay.
Exactly. So this is what we did here. So I checked which commit I wanted to retrieve the pointer file from. So this is very important. I wanted to retrieve the pointer file from, and then I use git checkout to retrieve this file.
Great, it's clear. Thank you.
Amazing. Any other questions? Dean, anything that you want to add about the DVC 101 before we dive into the DVC 102?
So maybe it's a bit related to Uri's question, but I think that Nir is now explaining to you sort of the insights of DVC. And in the day-to-day, unless there's something very advanced that you want to do, you're probably not going to interface with the contents of the .dvc files. But you're just, the way you need to think about it is as pointers. So if you go back to a version of your project, that version includes all the necessary pointers for your data, for your models, for whatever other artifacts. And once you do DVC checkout, DVC automates the process. So if you had to remember the hashes yourself, then DVC wouldn't be saving you any time. So DVC remembers all of that stuff for you. The only thing you need to remember is to, when you change a version of data, you need to do DVC add or commit, like David said, and then git commit, and then you're good to go. That's the only thing that you need to do.
I'm continuing on the same subject. So is it a good practice, like in the git commits themselves, like to add, like I also changed the data, added so-and-so rows?
So you mean like describing
message?
in text, in plain text, what you did? Yeah, so.
Yeah, I mean, if you're saying that it's like you're going back to a version of your project, so I would imagine maybe it would be a good practice to also say, okay, I changed the code, and also now the data has 50 extra rows.
So this is the way to do it. So you also, I would emphasize it. This is how you should do it, because if you won't have a informative git commit message, you won't be able to know what this version of the data files really stores. So it's important to state if you had a different processing method, or did you add more rows to the data. And I can tell you from a conversation that I had yesterday, a small talk in a birthday party with a data analyst, and he stated that it's very hard for him to understand what difference were made to the data versions. And I told him, listen, are you using a DVC or Git to version your files? And he stated that no, they're simply having more and more files, and they're only changing the name of the files. So yes, informative commits commit messages are very important.
Yeah, I agree. If you fix a bug, you write in the commit message, I fixed the bug where X happened. So if you fix a data bug or improve the data, then you want to let people know about it.
If I can just add one more thing, is something that it's very convenient for me is to like create different branches for different aspects of the project, and to track DVC files within those branches. So if I'm working with a friend, so he can check out my branch and DVC checkout. So that's very convenient for us instead of returning to previous commits.
I'm smiling because this is exactly what we're going to cover in the next part of the presentation. What will be the workflow that we recommend on. So this is exactly it. It relates to how to track our experiment and explore new hypothesis, even if you're working by yourself, and even more when working in a team. So this is a great point.
Cool.
I don't know if there is extra credit here, but Costa, you need to write down some extra credits here for the questions and comments. Okay, so we're going to cover next the DVC 102, as I mentioned, and I think it's very important for an open source data science project, and this is where the power of the community really comes to play, because let's say that now you explored a project on DAGsHub, and you think that the data can really help you, or you want to reuse it, or even you want to use the process data and not just the raw data. And DVC allows us, one of the very important features for the community, I think, in DVC is it allows you to import data files to your project from a different repository and automatically track them. And another side note here that you're going to use these commands in your hands-on experience. So it might be DVC 102, but you're still going to need to implement it later on. So another pay attention note here. So our current directory, our local directory, stores our universe.txt file and the pointer file, the universe.txt.dvc. And now what we want to do, we want to import files from a different project. So in this case, I'm going to go to a DAGsHub repository, and under the student workshop NLP, whatever, I want to import the files that are in the split data directory. I want to import the xtest, xtrain, and ytrain. And how can I do it using DVC? I can use the DVC import command. So I'm going to use DVC import, and then I'm going to state the name, the URL where the files are stored, but it's going to be to the main repository. This is a very important note. There is a space between this line and between this file that we state that we want to import the files from. So this is not one long line. So please pay attention to that, because it can be confusing. So we're gonna state the URL where to the repository, and then the path inside the repository, which is split data. And now, if I'm gonna check my current directory status, so I can see that the split data directory was added with all of the CSV files, and also I imported the pointer file that points to the version that I imported from this remote directory. And why do we want it? Because it enables us, so let's say I'm referencing data files from Dean's project. And in a month or so, Dean decided to go back and process his data differently. And I want to import the changes. So with DVC, it will be much more easier to import the new versions of the files, because let's say the Y train didn't change. He only changed X-test and X-train. So DVC will know to only import those two new files. And this is a very powerful, I say, features that DVC has that enable us to work and grow as a community. Okay, so I think so far we covered all of the basic features and workflow and even the advanced DVC workflow. Do you have any questions about what we covered so far? Something that you want to ask, an advanced questions, something about DVC, about Git, about the usage, about how we use them both, anything that comes to mind? Move the slide because it can be drive you crazy. Okay, so Dean, you want to add anything? Great, thumbs up from the boss. It's always a good sign. So let's take a short break, a 10-minute break, and I see that it's, let's regroup at 7:00. Okay, I don't know if Kostya here to play the music, but 7:00, let's be back here. So if you're here, please send the plus or whatever on the chat so we'll know that you're here. Any more pluses? If you're here, please state that you're here, and so I know that I can continue. I'll take another 30 seconds. I'm going to share my screen meanwhile. Okay, I think we can carry on. So, welcome to the final part of the lecture. And in this part, as we stated before, we're going to cover how can we track our experiment and manage a data science project. And when talking about experiment tracking, there are two main approaches to do so. The first one is external tracking, which means when executing your experiment code, when running your machine learning code, you simply make calls to log the experiment information to some database, which later on displays it. And when using Git tracking, it means that every experiment becomes a Git commit. And we'll later on going to see how we can do it, each one of them, how we can do each one of them. But let's first start talking about the pros and cons of each one. So when talking about external experiment, the most straightforward pro here would be that there are very good existing tools to do so. We have TensorBoard, we have MLflow. We can just either dump everything to an Excel sheet or Google sheet. And this process is very intuitive. It maps directly to our intuition of what's going on. We have an experiment and we're simply going to turn it to a row in our table. However, it's easy to get spaghetti. And I really like eating spaghetti, but I don't like it in my machine learning project. it can get you to a point where you have a huge table of experiments where you have no idea where each experiment came from. It's hard to compare apples to apples. Let's say one experiment was all about data versioning or data processing, I'm sorry, and the other one will be all about hyperparameter tuning. Is it really makes sense to compare the two? Secondly, it's related that it's not clear what code produces this output. You can't connect the run, the log, to the code. It's very hard. Thirdly, it's hard to review the project, especially when trying to go back to a project that you or to your work from 2 weeks ago. You probably won't remember which experiment is referring to. And this brings me to the last point, that reproducibility is not well defined. It's not always clear how we can reproduce the run. We need to remember what hyperparameters did we use, what models, what kind of data did we use to train our model. It's very hard to reproduce those runs. However, when talking about tracking it with Git, the most valuable thing that we're going to have here is the ability to reproduce. It's going to be easy. There is only single source of truth here, and we can reproduce our entire project easily as simply as Git check out the code and use DVC, for example, to check out to our previous data and model files and the experiment output. So reproducibility is very easy. Also, we have the experiment with our context when we know what produces those experiments, and working in parallel is very easy. This is why this is what Git was designed for, to work in parallel simultaneously and while working on isolated environments. And lastly, we can use GitOps or CI/CD to automate our project and process and integrate with the Git ecosystem. However, it can become a bit complicated when growing with the amount of experiments, although this is not actually a problem in theory, but currently the tooling don't handle it very gracefully. We can use, I don't know, a remote server to simply choose which experiments are the most valuable and only present them. But it's less intuitive to us to use Git to track our entire experiment. And I would say that the bottom line here, that mixing and matching is always an option. You can use both methods when working on a project. For example, you can use the external tracking when you start to explore a new hypothesis or a new processing method or a new hyperparameters tuning. And only when reaching to a valuable experiment or to a valuable result, then you encapsulate it with Git and DVC to track the entire experiment and what resulted to this output. Any question about the different methods here, or what we define as the two methods? Okay, so let's dive into how. So when talking about external tracking, we have MLflow, which is a very powerful tool that enables us to manage our entire machine learning project end to end. And MLflow has three main branches. The first one is the tracking, which we're gonna cover today. And it's an API for live logging of parameters, metrics, and metadata when running a machine learning code. It has the project where it enables us to package our code file in a reproducible way. And it models, which enables us to save our model in a standard format for packaging our machine learning models. And as I said, we're going to cover today the training branch of MLflow and how we can use it. So how does MLflow tracking really works? So you can take your notebook, application, cloud, whatever, and edit the MLflow code that enables you to log it to either to your local machine and your local UI or to a remote server. And by simply pip install the MLflow package and then import it to our module, and we can log the parameters or log our metrics. And then with MLflow, we will be able to see it either on our local machine, as I stated, or to log it to our remote MLflow server. However, to every good tool, the same as DVC, it has its dark sides. And what do I mean by that? To make MLflow tracking output accessible outside our local machine, we will have to host it on a remote tracking server. And once again, to define this server, it can be a hassle. And once again, we have DAGsHub to the rescue. And what we did, we automatically connected all of your to your repository an MLflow tracking server that you can easily configure and then log your experiment to. And all of the results are going to be logged to the experiment tab. And how can we do it? We're going to once again go to the remote button in our DAGsHub remote repository. We're going to choose the question mark next to the MLflow tracking. And then we're going to have all of the configuration that we need to configure MLflow. However, there's a lot of different ways to configure MLflow to use it if you're using it in a notebook or locally. And you can have all of the different options to see the documentation in DAGsHub or in MLflow. And once using this way to log things, this is how it's going to be. You're going to see them in DAGsHub under the experiment tab. So you will have the source where you use to track this experiment, either MLflow or Git, that we're going to cover in a sec. And then what you log there, if it was the parameters, if it was the metrics, and if the experiment successfully ended, meaning if the run of the code ended or was interrupted. And another powerful feature that MLflow has, that it enables us first to log experiment from different machines to the same UI. So let's say one is running a model that is more of a data-centric and is trying to use different data set to train the model. And someone else is trying to to tune the hyperparameters of the model. You can both log those experiments to the same place and see the result live. So if we're talking about deep learning models that are more relevant to this, we can see the progress of the model in every epoch and step. And this is very powerful to understand how the model is being trained and if it's useful or should we stop the run. And this will be it about the external tracking and how we can use MLflow to do just that. And it's, as you can see, very easy, and you can simply add the MLflow code to your machine learning code and run it again and again, and it will be logged to this table. Nothing else is needed.
Could you please go back to the previous slide?
This one?
Yeah, there's lines of code at the bottom.
Mm-hmm.
Where should we put them? Is it part of the Python file in the environment? Where do we run them?
So this is a good point. So some you need to define in your Python module. So you need to define the URI that you want to log to. And some you need to define as environment variables. So I don't want to go very in deep on how we're gonna do it here because there are various methods, and I don't want to confuse you because it's very important to have your own way of doing it because you can accidentally log your experiment to a different project if you're not defining it properly. And this is why you're going to have everything under our documentation. Dean, you want to add something here? I see that you...
Yeah, so the example code that you see here, you can basically copy and paste it into your terminal. You then need to edit the password that you see, your password, and the script.py, you need to change it to the script that you want to run. And then you hit enter, and it should run and log everything. There are other ways to define, for example, the MLflow tracking URI, as Nir said, but this will cover you end to end, assuming you modified your code to add MLflow logging. So within, let's say you have training.py, which trains your model. Within training.py, you're still going to have to do import MLflow and then do MLflow log params and whatever, log the different parameters. But this, assuming you did that, you can just copy and paste this, change script.py to training.py, add your password, and you will see the run log without you don't, in this case, you don't need to set more environment variables, for example.
Thanks.
Sure.
Okay, so next off, we're going to cover on how to use Git to track our experiment and encapsulate it under one version of the project. So if you're working with DAGsHub to use the Git tracking method, all you need to do is track and save your parameters and metric in open source format files, as you can see here, to params.yaml and metrics.csv. And once committing them with Git and pushing them to DAGsHub repository, we will scan your commit. We will look for those files, check if they were modified. And if they were modified, a new experiment is going to be generated under the experiment tab. And with those files, we highly recommend to also version the entire project that you use Git to version, let's say the code files, and to version your data and model files using DVC. And in this way, you encapsulated the entire state of the project with the result of the model, the metrics, and the parameters that you used. And if you want to retrieve the result, it will be as simple as using Git checkout and then DVC checkout. And to help you with this process, we created the DAGsHub logger. And this logger is a simple Python logger, which you need to use pip to install. I recommend here also on your virtual environment, and then import it to your Python module. And you can either use it as a context manager to log the metrics and the hyperparameters, or as a normal Python object that enables you to, once again, log the hyperparameters and metric, but please remember to save and close it. And once you're going to use this logger and the run is going to end, this logger is going to output the information to these two files. And when pushing them to DAGsHub repository, we're going to parse them and show them under the experiment tab. Any question about the how to use the Git tracking?
It's an alternative to the previous MLflow method.
So there are both two methods on how to log and track our experiments. The previous one, as I stated, is not that reproducible, but it's a simple and fast way to simply log the experiment and runs either to your local machine or to DAGsHub under the experiment tab. However, by using the Git tracking and making the entire project state as a commit will enable you to go back and reproduce those results easily. So those are two methods, and those are the main pros and cons of every method. And it's for you to pick. And I highly recommend mix and match between those two methods based on the stage that you're in the project. So if you're in the early stages of the experiment or the exploring of this new hypothesis, then yes, using the Git commit can be a bit of a burden and take a long time. But if you manage to reach a very good result in your project with your model, I highly recommend encapsulating the status of the project under a Git and DVC commit to be able to reproduce those results easily if needed. Dean, anything that you want to add here?
Just sort of a solution architecting a bit. You probably want to write the code that lets you log to both, and then either log to both at all times and just commit to Git when you want, or have like a flag that lets you choose what you want to log to. Just because if you get to the point where you have an experiment that you're happy with in MLflow, and then you say, okay, now I want to commit it to Git, and you didn't create the metrics.csv and the params.yaml, then you need to run it again or somehow export from the MLflow the metrics. So I would recommend having the code for logging ready anyway. It's not something that it's extra effort, assuming you know what you want to log. So it's the same, like you can copy and paste it, and then choosing where you want to log something to, or again, logging to both.
Any further question about experiment tracking and how we can use it to manage our data science project? Any insight that you had that you want to share?
I must say I didn't really understand like what MLflow is for. Like I understand how to like set up the remote address and in general, but how to use it? What is it for?
So for every, let's say, for every one runtime, so for every new experiment that you're going to create or training the model, maybe you would want to log the result somewhere. So instead of copy and pasting the metrics to an Excel sheet, MLflow enables you to simply add a few lines of code, and it will save and log the metrics and the parameters and save it to a database and then present it in its UI. And if you define it with DAGsHub, you will be able to present it in your project repository. And if you're collaborating with other people, they will be able to see your results.
So I have some like log lines in the code where I do log metric, something like that. And how does it connect with, for example, the version it was running on?
So it doesn't really connect. It doesn't connect. It's a simply way to log the output of the experiment and the metrics that you used. So this was the downside of using external tracking and simply log it to a database. It's easy, it's fast, but it still doesn't enable you to reproduce the result. It's just a way to keep track of what's going on in the project.
Cool. And you so far covered only the logging part of MLflow, right? You didn't cover other parts, just to make sure I didn't miss.
No. So MLflow has other branches that we're not going to cover today. We're going to cover only the tracking part. And for the Git, the Git tracking was clear to you, how to use it and how to encapsulate all of our projects when using DAGsHub? Yes, no. WH question.
So maybe to give concrete use cases, what you might do with MLflow that you can't do with Git is, let's say you have a deep learning model and you're going to train it for 30 hours. You probably want to know after a few hours whether or not the loss is converging. And for that, you need something that's real-time logging so that you can see your charts in real time. And Git does not really do that. So you can theoretically write it to a file and open the file in real time locally and then plot like the loss or something like that. But it's much less convenient than just logging it to MLflow and seeing in real time the loss converge or not converge. And then you can stop the run and things like that. That's like a use case for MLflow. And also sort of imagine you're now like trying a bunch of things and maybe things aren't working so well yet. So you sort of run an experiment, then it throws an error, then you run another experiment, it throws an error, but you want it to log stuff because once it does work, you just want to run it to the end. So MLflow is good for that. And then once you have an experiment that you want, so what MLflow does with respect to reproducibility is it saves the Git commit that you started it from, but it doesn't save changes. So if you start from a Git commit, you can change a bunch of things, and MLflow will not know that. So what we're basically saying is, you imagine you're trying a bunch of things, and then you realize that, I don't know, your GPU is not strong enough to run ResNet 50, but it is strong enough to run ResNet 18. So you decide to do the run with that after you change the architecture a couple of times. You finish training, and now you want to commit that experiment with ResNet 18. So now what we're recommending is you make sure that you have that also in Git. And now you have like 4 runs of MLflow that maybe some of them worked well, some of them didn't. Now you're going to say, okay, Git commit this experiment, which has like the data, the final model, the parameters, the metrics, and use that as sort of like the source of truth. Because if I then want to reproduce your work, then I can just do git checkout, DVC checkout, and I have a copy of that. If I'm only relying on MLflow, then it's not guaranteed, basically. That's the idea.
MLflow also saves the local copy that I can later commit. Like in addition to sending it remote, it also creates like a local metrics file with all the
So
logic.
it saves metrics, but in a very problematic like structure. So it might become a very big folder. So then you can theoretically commit it to like as a DVC artifact, but that's kind of like a solution like this. It's probably better to log it as a proper CSV and YAML file and then commit that.
Okay.
Does that make sense?
Like you mean when I say YAML file and CSV, like to build something custom myself, like to use MLflow just for the runtime? Sorry?
You can use the DAGsHub logger to log the metrics and the params.
And DAGsHub logger, is it working only with DAGsHub server, or can I use it?
It's a simple Python logger that eventually we built on top of the logger, the feature of exporting the metrics and the hyperparameters to those open source format files. So if you're going to use this logger, it will eventually output the metrics to CSV file and the parameters to YAML file.
Okay, cool.
It's probably DAGsHub logger is a bad name because it's not like the team at DAGsHub built it, but it's not really related to the platform. You can use it to generate the logs and the parameters in a generic format, which you can then, you can open it with Excel, which is very convenient.
Cool.
Any other questions about the MLflow tracking, about the Git tracking, about how to use the experiment tab on DAGsHub? I think it's a very powerful tool to manage our project. So I do want to take another minute for questions if you have here.
Yeah, Nir, I have a question about this slide, about the DAGsHub logger, maybe a clarification. Like we would want to actually, instead of writing loss equals 3.14, to give a parameter of our model, like loss equals model loss, or am I not understanding it correctly?
Definitely, you do want to work this way. Moreover, to log your hyperparameters, most of the time you will have them logged, and you will be able to export them from the model in a more easy way and all at once. So also for the hyperparameters. So definitely.
Thanks.
Okay, so I think we're ready for the hands-on experience. And the hands-on experience will be a competition that is gonna go in the following week, where the winning team, I'm gonna start from the end and not from the beginning, where the winning team is gonna win 100 gigabyte of free storage on DAGsHub platform for your project for your entire life. So this is the prize and the competition. So I'm going to start with sharing with you the competition instructions. Let's do it over the chat. No, so it's gonna be under your, gonna be also in your Slack channel, and I'm gonna send it in the chat here, so you will have it. Great. And what is this competition? So basically, we created a competition that it's more oriented to production. And why is that? And how is that? So we're basically asking you to create a model that we can easily reproduce its results while using DVC to track and version your models and data files, and use the experiment tab and the tools that we have on DAGsHub to work in a team to track the different components and to easily compare the different results. So this is in a very high level. So basically the task, you can read it here, but we want you to build a model that performs with the highest F2 score. You will have here the data set. We want you to keep track and save the different data and model versions using DVC. We want you to push the DVC tracked files to your DAGsHub repository while using DAGsHub storage. And I would say that this is a very important part to enable you to version your data files the same way as we would version them in a production-oriented environment where you will work in a team, and each team member will work in a different on a different component, and you must log it properly in able to reproduce your results. You can use DAGsHub Logger to track your outcomes. You can also use the MLflow tracking to track the results. You can see here the data set and the submission. So the short version of it, it's the only submission will count. Don't overfit, because the secret data set is going to be the one who is going to determine the winner, the same as Kaggle competition. And you will going to be evaluated based on your leaderboard and the repository and the way that you manage your work. So about the leaderboard, you can find the leaderboard here with all of your submissions. You're going to submit your prediction of the Y test set. By the way, all of the data sets are saved on DAGsHub servers, and you need to import them with DVC, the same way that we learned in the DVC 102, if you remember. You will have there only the X-train, X-test, and Y-train. The Y-test is going to be stored on our leaderboard backend. And then you're going to try and predict the Y-test and submit it and submit your prediction to the leaderboard. You're going to see the code snippet in a second. Then in the backend, we're going to split your submission into test or maybe public score and secret score, where for every set, the F2 score is going to be calculated and saved. While the competition is still ongoing, only the public score is going to be visible to you, while the secret score is going to be saved behind the scene. When the competition ends, we will flip the switch that it will disable any further submission, and it will reveal the secret score. And in this way, you won't be able to overfit to the public test set and win by cheating. So the winning team is going to be choosing based on the secret score ranking. Please make sure that the submission that is going to count is the last submission. And this is why reproducibility is important, because if you want to check how your model performs and submit many times, you're going to have to be able to reproduce prior results that are better than the last result. So this is why it's important. And now you can submit. So here you have a code snippet. And let's say that you have your prediction in a list. you will simply need to copy and paste this code, which dumps the submission to a JSON with the name of the submitters, which we're going to cover in a second. And then it's creating a request to our leaderboard, which is going to result with the name of the team members, your ranking, and your score. You're also going to be able to see your ranking in our leaderboard UI. And for the teams, so the division of the team is here under the Google Sheets. You can see it. It's based on your deep learning projects. So there is no need to print screen. You will have it as a link in the Notion page. And this is the username that you're going to use for posting the results. So this is pretty crazy that you have Noah and David and another David and Noah in two different teams. So you have your full names as your username, but this is what are the odds kind of thing. And this is it. So you're going to use the name of the team to submit. You're going to submit the result. This is the code snippet. If you have any question about it, you can feel free to ask me. And as I said, the evaluation is going to be based on two criteria. First, the 90% is the leaderboard, and 10% will be your workflow and our evaluation of your repository, the way you log things, and how able are you to reproduce the prior result. The deadline, we're going to flip the switch next Sunday, April 18 at 8 in the evening. So you will have pretty much a lot of time to work on it. If you have any questions, we're going to support you during this week in the DAGsHub channel, in your Slack channel. Feel free to ask anything there. If you have questions about the platform, how to use DVC, how to use Git, how to create a new repository, or maybe advanced questions if you're using, which we highly recommend, using two different branches and then creating pull requests that each one of the team members needs to review it and approve it, the same way that you're gonna do when you work as data scientists in a production-oriented environment. And that will be it. So we'll have another 25 minutes that Dean and me are gonna be here. And if you have any questions during the work now, you can ask. And if not, I wish you the best of luck, and may the best data scientist win, I would say. Dean, you want to add anything?
No, it was a pleasure being here, and let us know if you have any questions.
Any question about the competition? About the submission part, how to do it? Amazing. Okay, so let the games begin, as they say. Begin. Good luck, everyone, and you're welcome to stay here and talk with us if you have any questions. And if not, I wish you best of luck. And it was a pleasure being here today and talking with you. And hopefully, we're going to see some great results. Bye-bye for me.
Bye, everyone.
Bye-bye.
Thank you. Bye.
Thank you, Nir. Thank you very much.
You're welcome.
Bye bye. Thank you.